We're going to talk about lists, which are kind of the workhorse of Python programs. So lists are mutable, meaning they can change, sequential collections of Python objects. So two key points here. They're mutable as contrasted with strings, which are immutable. And they're sequential like strings, but different than dictionaries, which we'll get to shortly. So with lists, we can have lists of a variety of collections. They don't have to be the same thing. So I don't have to have a list of numbers and a list of strings. I can have a list of numbers and strings and lists. In fact, a list can contain any Python object, a number, a string, and other lists, functions, etc. And I will illustrate this in a second. So we can create lists with square brackets, such as here I'm creating list 1, which is a list of the numbers 1, 2, 3. Here I'm creating a list 2 with the numbers 1, 2, 3 and the strings 1, 2, 3. And now I'm creating a list 3, which consists of the numbers 1, 2, 3, the strings 1, 2, 3, and a list of the strings A, B, C. Don't actually print these out, but we could. Let me just, I'll print out list 3. So here we take our square brackets and we put in between it all the things we want to have on our list. So lists can also be created with the list function from other sequences. So here I'm creating a list from, in this case, this is a tuple, 1, 2, 3. Here a list from a dictionary, and here a list from the string Brian. So some things to note here. Okay, so whereas I pass it the dictionary, which details will come later, dictionaries consist of a key and a value. We ended up with just the key or the value, so let's see what it ended up with by changing that. And see what we're ending up with are the keys from the dictionary. And here I pass it the string Brian, and you see when I made the list of it, it broke that string up into the individual characters to make a list of the individual letters. So I have this question, what's wrong with the following code? So I have list of 1. If I run this, I'm going to get an error. It says type error int object, which is the 1, is not iterable. So it's not a collection of things that we can select from. So that's essentially what you have to create a list. Okay, we can get help on the list function or classes. So range, and I have a link here to the documentation on range, can be used to create lists. So a range is actually a distinct sequence type in Python. Details we'll get into later in the class. So we would convert a range to a list with the list function. And range will become useful when we start talking about for loops. So here I'm creating a range and it's returning this range object. Here I'm taking a range, giving it the argument of 10, and just like slicing, range has a default start, which assumes you want to start at 0, and a default increment, which it assumes is 1. And so in this case, when I use range, I'm going to get a list that's going to be the numbers 0 inclusive up to but not including 10. So we get the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we're doing the same thing, but we're skipping every other number. So we get 0, 2, 4, 6, 8. We can also use the range to count backwards. So here we're going to go to 10, 9, 8, 7, 6. And you can see the same thing. our starting point is inclusive, our ending point is exclusive. We don't actually include 0 in the output. We can make empty lists. We can have lists that include empty lists, and we can set variables. So here we declare the variable A2, which is this list. We set B equals to A2. And one thing you need to be careful about is that B is referring to the same object as A2. So if we print B, we get the 1, 2, 3. Okay, well, I better do that first. So we got the 1, 2, 3, 3, 2, 1 empty list. So now if I take B and I append Brian, this is one of the ways that we add something to an image, a list. And I print it out. Now the last element is the string Brian. But all we did was change B, but we see that A2 is also changed. So B is essentially like an alias for A2. They're referring to the same chunk in memory, so when I change one, it's going to be reflected in the other. So just like strings, we use square brackets to retrieve the content at a specific index in the list. Okay, so I guess I could add, let me add a cell right here. So if I want to get the fourth element of A2, so remember fourth element because we're going to have 0, 1, 2, 3. I get the number 3, or I could change this to, well, Python does have a funny thing that I can count backwards from the end of the list. So -1 is the index into the last position in the list, which is Brian. And then I could index into that string to get the letter B. Okay. Okay, how do we insert data? So as I just showed you before, we can append, which will stick something at the end. There's an insert function. There's an extend function. And I can concatenate with the plus symbol two lists. So let's go over a little bit of this. So I start with an empty list, A. I append Brian. And then I'm going to insert the number 39. So insert takes as an argument where I want to insert it. In this case, I'm going to say into the 0th position, the beginning position, and what I'm going to insert. And so we should now have a list that has 39 and then Brian. All right. Okay, here I'm going to insert into A list of 5 numbers, and I'm going to put it at position 1. So then that should show up between 39, which is at position 0, and Brian, which was at position 1. So we'll now have a 3-element array list with 39, our list of numbers, and then the string Brian. All right, here I'm concatenating 2 lists. So I create a list 1, 2, 3, another list 4, 5, 6, and I add them together. And I'll have a list that's 1, 2, 3, 4, 5, 6. Let me split that to show this. Right now I'm going to create a list 1, 2, 3, and I'm going to extend it with a list AB. So now I should have a list 1, 2, 3, AB. So we get there. Now I create a list C with 1, 2, 3, and I'm going to append it to the list AB. Now here we're appending, so we're adding an element, and that element can be anything. In this case, it's a list. So what I'll now have is a list of length 4. The number is 1, 2, 3. And a list consisting of the elements A and B. So we can time what are the efficiencies associated with modifying lists. I'm going to skip over this. You can play with it. This is using the time it magic. And I'm comparing using these built-in list methods to looping over the list with a for loop. And what you'll find is looping over it is slower than other ways of extending the list. So just like we did with strings, we can do indexing to extract specific elements of a list, and we can do slicing to pull out chunks of the list. And for the sake of time, just going to print that out. You can play around with modifying the pieces that you're pulling from. Okay, so other ways that we can modify data is we can change the value at a specific location through assignment. And we can do that for a single index, or we can do assignment by slicing. We can sort lists. We can reverse the order of lists. There's a pop function which will pull out a value from the list and delete it, return a value from the list and delete the value that was returned. And then there's a delete function that we can use to delete specific elements of the list. And you can get the help on pop. So pop takes an optional list of indexes, and it's going to remove them and return them to you. And by default, it's going to remove the last element of the list. So if I don't tell it anything, it's going to pop off the last element, return that to you, and delete it from the list. So here's some examples that result from that.